Hey everyone, we're going to start a new chapter. We're going to do some algebra. So today we're going to do algebraic expressions. So in order to do this, what we want to get familiar with is some words that suggest you're talking about addition or subtraction or multiplication or division. You know what I mean? Like if you're hearing some word problem or some question, what are some words that would make you think, hey, I think this might be an addition question? Well, the real mathematical word for it, I suppose, is sum. If you have a sum, it means you're adding two things together, and the answer is a sum. Or maybe you're adding more than two things, but you're adding, and you're getting an answer, which is called the sum. But there's other words that definitely are kind of a hint that you're talking about addition. How about plus? Or maybe together, increase, more or more than, greater. More and greater kind of mean the same thing, right? Greater. So it gives you a sense. There's probably more, but those are the sort of words we're talking about. Subtraction. The real word for math is difference. If you have an answer that you got by subtracting, then you have just found a difference. But what are some other words that suggest you might be doing a subtraction question? Well, minus. Or think about what you called it when you were a little kid. You called it take away. How about less? Increase for sum, well, decrease for difference. How about reduced? Okay, there's a good list there. Multiplication, the real word for an answer in multiplication is called the product. If you multiply some things together and get an answer, you found a product. But other words that suggest multiplication, times, that's what we actually usually say, times. Believe it or not, of, the word of means times, especially when you're talking about fractions. 2/3 of something is 2/3 times. How about twice or triple? If you have twice the amount of something, you have 2 times as much. If you have triple the amount, you have 3 times as much. And maybe one more I could write is groups. When you talk about groups, you're often talking about multiplication. However, when you're talking about groups, you could also be talking about division, so that can be a little confusing. All right, the real word for division, when you get an answer, the answer is called the quotient. Hard to think of other words that can make you think of division, but there's a couple. How about goes into? Or maybe over? I don't know. I'm reaching here. I don't have many for division. Okay, now why have I taken the time to look at all these? Because what we're going to look at is writing expressions, writing algebraic expressions. So what's an algebraic expression? It's a combination of numbers, variables, wait a minute, what are those? We'll get to it in a second. And operations, what are those? Used to represent a value. So numbers, you know what numbers are. Variables, do you know what variables are? Variables are letters used to represent unknown numerical values, right? If you want to represent some amount, but you don't know the number, maybe not yet, and you're going to solve it or whatever, you're going to use a letter to represent it. Now in math, the usual letters we use are X. Sometimes instead of writing the X like this, because it looks like a times sign, you might want to write the X like this. Although, to tell the truth, I usually don't do this. I always forget to do it. But you could write the X like that. Y is very common. Z is very common. M is quite common. N is common. I would say those are the 5 most common variables we use in math. But you can use any letter you want. There are some I don't recommend. I don't recommend using a small L. Looks like a 1. Terrible idea. O's not so good. Looks like a 0. So don't use that. T's not so great. Looks like a plus sign, right? I would say these ones, I really discourage them a lot. See what I've done there? Yeah, anyway, I don't think those are good letters to use, but you can use them if you want. It's up to you. These are the ones we usually use. Okay, constants. A constant is a number that's all by itself. It's all on its own. It's not multiplying variables. Because here's the thing. When you multiply a number by a variable, like if you're multiplying 4 times m, let's say. Okay, you could write it like that, 4 times m. Or you could write it like 4 dot m, because remember that means the same thing, that means times. Or the fastest and best way to write that is to write it like 4m. Okay, that's how you write multiplication when you have a variable. Now, this is not a constant. This 4 is not a constant because it's multiplying the m. But if I had something like 4m plus 4, then this 4 over here is a constant. This one here is a constant, and the other one, you'll learn this next year, this 4 is called a coefficient. If it's attached or multiplying a variable, it's called a coefficient. Anyway, don't worry so much about this. It's not a big deal this year. We'll talk about it more next year. Oh, I have one other thing to say about expressions. Expressions can be simplified, which we're going to do on the other side of this page, but you're not going to solve them. We'll solve equations, not expressions. We'll solve equations later, but for today we're going to simplify, and I'll show you what I mean in a second. Alright, so the first skill we need to do today is we need to figure out how to write expressions. They're going to give us some words and we have to put it into algebra. We want to use numbers, we want to use variables, and we want to use operations, which I've forgotten to explain to you. The word operations shows up right here. What are operations? Operations are like the things you do in math. You do addition, you do subtraction, you do multiplication, you do division. You can square or cube, you can do cube root or square root, right? These are all operations. So we're going to mostly work on the first ones, add, subtract, multiply, divide, and we're going to use variables, and we're going to use numbers, and we're going to represent all these things. So the first thing I see is 4 more than a number. Okay, well, this number here, I don't know how much that number is, so what should I do? Well, you're going to give it a letter. Give it a letter to represent it. Use any one of those you want, or use your own letter. I don't care. I'll use M. So, M is the number. But what I want to show is 4 more than that. 4 more than a number. Well, more, that sounds a lot like a addition step, doesn't it? And that's exactly what you're going to do. You're going to take this number and you're going to add 4 more to it. This is 4 more than a number right there. Now, what if you wrote it this way? Is this okay? Sure, when you add, the order doesn't matter. This is still 4 more than a number. Now, someone could argue this is m more than 4, but either way really works. I do think the other one's a little more accurate, but it's up to you. I will take either one of those. This one, you gotta be careful. It's 6 less than a number. We don't know the number. I'll call it n this time. Now, I want to do 6 less than that. So, 6 less. Less sounds like we are subtracting. There's less right there. So, n minus 6. Or is it 6 minus n? Or can either one work? No, only one of these is right. When you subtract, order matters. We have 6 less than a number. In other words, you want to start with the number and do 6 less. Take off 6. This is incorrect right here. The only answer that works is this one right there. You could have a different letter, but you need to have the letter, take away 6. Okay, the product of 7 and a number. Product, that means multiplication. So we are going to multiply 7 times a number. What should we call it? I'll call it y this time. 7 times y. It's right. I'm not enthused by that answer, but it's right. Oh, you might put 7 times y. That's also right. Still not totally enthused. You could also write 7y. Oh, now I'm happy. This is the answer I like. This is the answer I like most here. This is the only answer there. Okay, the quotient of 5 and a number. Quotient, that is division. We're going to divide this time. So, the quotient of 5 and a number. So, here's another thing. When we're talking about algebra, equations, expressions, try to get out of the habit of going 5 divided by n or whatever. Instead of doing that, what will make it a lot easier when you're solving equations is if you do 5 divided by. Just put it right over top like this. So 5, the quotient of 5 and a number, I'll call the number z this time. So 5 divided by z. Or, should it be this way, or does either one work? Only one works. The ones you have to be careful about are subtraction and division, because order really matters. If it just tells you the two things, you have to put it in the order it says. The quotient of 5 and a number. 5 and a number. 5 divided by a number. This is incorrect. This is the only answer, although you could have a different letter. Okay, a couple of tough ones down here at the bottom. Triple the difference of 5 and a number. whoa, triple the difference of 5 and a number. So the first thing we actually need to get here is to figure out what's the difference of 5 and a number. We got to get that first, then we'll do the triple part. So the difference of 5 and a number. Difference. Difference means subtraction. So we have to watch our order here. We're getting the difference of 5 and a number. You got to put it in the order it's written this time. 5 and a number, which I'll call x. So right there here, this is the difference of 5 and a number. But we want triple that. Triple means 3 times all of that. So how am I going to show that? If I want to do 3 times all of this, I need to put this in brackets and then put 3 times out front, or 3 dot out front, or even best, just put 3 out front. This means 3 times the difference of 5 and a number. Now this is hard. I think it's harder than anything in your workbook. This is like a level 7-8 sort of question. This is more a grade 9 question. But I thought I'd just show you. Here's another toughie. The sum of a number and 2 divided by 3. So sum, what does sum mean? Sum means plus. And what are we adding together? A number and 2. Okay, so a number, well, why don't I call it F, just to show you I don't have to use those 5 ones I showed you above. I'll use F. The sum of a number and 2. So there you go. I've done the sum of a number and 2, and now I want to divide by 3. What am I dividing by 3? Well, believe it or not, because of that comma right there, right here, this comma right here, it means I'm dividing all of this by 3. So it would look like this, divided by 3. You could put this in brackets if you want, but you don't need to. Okay, this would be your answer. But I want to show you something interesting. What if it has exactly the same question, but we did not have this comma right here? Then it would be the sum of a number and 2 divided by 3. This would all go together now. The 2 divided by 3 would all go together. So in other words, you'd have the sum, you'd be adding, a number, I'll call it F again, but what you'd be adding to the number is 2 divided by 3. 2 divided by 3. This would now be the answer if that comma wasn't there. Oh my gosh! The English language, mathematics, both can be tricky, and we're putting them both together here. So that's not what the answer is to this question. That would be the answer if that comma wasn't there, but I just thought I'd show you how really, truly tricky this can be. Again, this is more grade 9. This would be a hard grade 9 question, doing the difference between these two answers here. Alright, if you get these black ones here, you're doing great. If you get the red ones too, wow, you are truly amazing. Okay, let's go into the other thing you need to know in this lesson, which is evaluating algebraic expressions. Evaluating algebraic expressions. What's that mean? That is when, well, first of all, it's only possible when you know the values for the variables. See, in this first question, they tell you x equals 3 and y equals -2. Oh, they've told us what is x and what's y. Now we can do some evaluating. And what you do is you substitute these values into the letters, and then you simplify. So, let's take a look. It tells us in this first question that everywhere we see x in these first 3 questions here, it's equal to 3. And everywhere we say y, it's equal to -2. So what we're going to do in the first question is, we're going to take this expression, this is an expression right here, x plus 4, and we're going to substitute into the x, however much x is. Well, x is 3. So what we're substituting in is, instead of writing x, I'm writing 3, and I still have this plus 4, and 3 plus 4 is 7. There you go. We just evaluated that expression. Now we could only do that if they tell us what x is. And if someone said, oh, I made a mistake, x is actually 10, then we'd put 10 plus 4 in there and get 14. But we need to be told how much x is or how much y is. Okay, in the next one, we have -3y and then take away 6. So I'm going to put -3. Now I have y, and y is equal to -2. Now be careful. Don't do this. Don't go -3 and then -2. It looks like -3 take away 2. When you are substituting in, a good safe practice, which I could have done back here too, is always put a bracket around the thing you're substituting in. So we substitute 3 in here. I could have put it in brackets. It wouldn't have changed anything. Here's -3, and I'm substituting in my -2, which I'll put in brackets. And I still have my -6. Right? So I put -2 where the y is, and I put it in brackets. Now, what does this mean? This is -3 and then -2. There's nothing in between them. That means multiplication. So this is a multiplication step, and this is a takeaway step. And what should you do first in BEDMAS, order of operations? You should multiply first. So the first thing you need to do is this. Negative 3 times negative 2. Two negatives make a positive, and 3 times 2 is 6. And we still have this minus 6. 6 minus 6 is 0. This expression here is equal to 0, as long as y is equal to negative 2. Okay, in this one, we're going to substitute into both letters, y and x. So we have 3, then we have a y, so in brackets I'll put negative 2. We still have minus 5. We still have plus 6, and it's divided by x. X is 3, and just to be careful, I'll put it in brackets. So there you go. So we have a multiplication step, we have a subtraction step, we have an addition step, we have a division step. What do we do first? We do the multiplication and the division first. This and this come first. So let's do that. 3 times negative 2. Remember, this means multiplication because there's nothing in between them. 3 times negative 2. Only one negative, so it's negative, and 3 times negative 2 is negative 6. Keep the negative 5. Plus 6 divided by 3. Well, 3 goes into 6 2 times. Not 3. That's a super common mistake. Alright, so now we have to solve this. Negative 6, take away 5, and then plus 2. Ugh, I hate subtracting integers. Why don't we keep the first one the same, the negative 6, but instead of subtracting, add the opposite of 5, which is negative 5, and then plus 2. You don't have to do it this way. I just like doing it that way, and I think some of you do as well. So negative 6 plus negative 5. We're going to do this part first. Okay, you got 6 negatives, you got 5 more negatives, you got a whole bunch of negatives, you have 11 negatives. 2 negatives do not make a positive when you add. It's only when you multiply and divide. So this is negative 11, and we still have our plus 2. Now, what do you got more of, negatives or positives? You have more negatives. How many more is 11 than 2? 9. Your answer is negative 9. Good old integers coming back to haunt you again. I bet for many of you, this will be the only part of this that you really struggle with. It won't be so much substituting the numbers in. It'll be the integers that show up. Okay, let me know if you need help, and good luck with the algebraic expressions.